Hi, 4th grade, Miss Kachabata here. Today's video is for week 6, day 3, and we are on the Eureka Math Module 5, lesson 19. Okay, so our learning target for today, our objective is I can solve word problems involving addition and subtraction of fractions. Okay, so for our warm-up, it says draw a tape diagram and record the given fractions decomposition into unit fractions as a multiplication sentence. All right, so I'm going to draw the tape diagram that represents this fraction first. So our first one, we have 4/5. Okay, so I'm going to draw a tape diagram. And I'm going to divide it into 5 equal pieces. All right, and then I know that this is going to be one whole, so I'll label that. And I'm going to shade in 4 units. Okay. All right, now I am going to label this, and I'm going to decompose it into unit fractions. So I'm going to say, okay, this is 1/5. Plus 1/5 plus 1/5 plus 1/5. All right. And then it says I need to record the decomposition as a multiplication sentence. So I can see that I have 1, 2, 3, 4 copies of 1/5. Okay. So that's all we're doing. If you weren't sure you needed an example, go ahead and pause the video now so you can go on and do the next 2 and then go over them with me to see if you are correct. All right, on the next one, we have 6/5. So I am going to draw my tape diagram. That is not what I wanted. Okay, I'm going to draw my tape diagram. Okay, and again, my denominator is 5, so I'm going to split this into fifths, but I know that there are going to be fifths in one whole, but I can also see here that my numerator is 6, so I know this is going to be a fraction greater than 1. Okay, so I know that first I'm going to have 1, 2, 3, 4, 5 pieces, 1, 2, 3, 4, 5. These 5 pieces right here are going to equal one whole, right? And then I have this piece right here because I have 6/5, right? So this piece right here is my extra piece. That is my 6/5 part. Okay, so I'm going to shade in 6 pieces. 1, 2, 3, 4, 5, 6. All right, and now I am going to write my sentence, my number sentence. So I'm going to decompose this into unit fractions. So 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. Okay, and now I'm going to rewrite that as a multiplication sentence so I can write that I have 6 copies of 1/5. Okay, so now I'm going to go to my next one, and I can see that this time it's in a mixed number. So it says 1 1/3. All right, so I'm going to think, okay, I have 1 whole and I have 1/3. So I know that 1 whole, if I'm thinking of thirds, is the same as 3/3. So if I have 3/3 plus 1 more third, I know that I'm going to draw a tape diagram that shows 4/3. Okay, so I'm going to take my tape diagram. All right, now I know that there are going to be 3/3 in the 1 whole, but there are going to be 4/3 altogether. So I'm going to split this into 4 pieces. But I'm going to draw my 1 whole over 3 pieces. Okay, because 3 is my denominator. So now I'm going to shade in 4/3. 1, 2, 3, 4. okay? And I'm going to decompose this as unit fractions. So I have 1/3, whoops, you need my pen back. I have 1/3 plus 1/3 plus 1/3 plus 1/3. Okay, and I know that that's the same as 4 copies of 1/3. Okay, you can go ahead and go on to the next page. All right, so these are just examples of using the RDW process to add fractions, all right, when they are in word problems. So, and then number 2 is an example of using a tape diagram to help you subtract a whole number and a mixed number. All right, so you can read through this if you want. I'm not going to go over it. I'm going to go straight to the word problems because we have a lot to do. And I will be teaching you there what all of this says. All right, this is really just if you're trying to teach yourself or you want to go back and look at some examples. All right, so we're going to go down to the let's try section. All right, and again, it starts with us just filling in some areas, and then as we move through, you do more of the work. All right, so we're going to start with reading the problem and underlining what we know and what we're trying to find out. So Sue ran 9/10 of a mile on Monday and 7/10 of a mile on Tuesday. How many miles did Sue run in the 2 days? Okay, so it says label the tape diagram to represent the fraction Sue ran on Monday and Tuesday. Okay, so it already wrote Monday underneath and Tuesday underneath. So if I go back to my problem, I can see that Sue ran 9/10 of a mile on Monday. So in the Monday box on the tape diagram, I'm going to write 9/10. All right. And then in the Tuesday box, she ran, the problem says she ran 7/10 of a mile. So I'm going to write 7/10. Okay. So now I have 9/10 and 7/10. And when I add up 9/10 and 7/10, I know that I can add these fractions right away because they have the same denominator. So 9 plus 7 is going to give me 16, and my denominator stays 10. So now I have 16/10. Okay. Okay, so let's go ahead and go back to, or go onto the next page. Right here, the little bubble says, add the parts of the tape diagram. How can you decompose the parts of the fraction? So we're going to go to the next page, and that's where we'll keep working to do that. So now you're at the top of the next page, and it has what we just did too. So 9/10 plus 7/10 equals 16/10. And now we're going to break up that 16/10, right? We're going to decompose it because we know that 16/10 is a fraction greater than 1. And a fraction greater than 1 always has a numerator that is greater than the denominator. So we know that 16 is greater than 10, so this fraction must be a fraction greater than 1. So I'm going to break up 16/10 because I want to pull out that whole number to simplify this fraction. All right, so I'm going to ask myself, since my denominator is 10, how many tenths do I need to make one whole? And I know that I need 10/10 to make one whole. Because remember, one whole in a fraction is going to have the same number in the numerator and the denominator. So things like 6/6, that's one whole. Or 8/8 is one whole, okay? Even 120 or 122nd over 120 seconds. That's a weird fraction. All of that is going to equal one whole. So now that I've pulled out my one whole, my 10/10, I'm going to say, okay, how many more do I have left over to get to 16/10? All right, in that 16/10, how many are left over if I pulled out 10 already? All right, and I know that I have 6/10 left over. So the number bond decomposed 16/10 into 10/10 and 6/10. All right, into those units, right? 10 and 6. All right, so now I'm going to put it into a mixed number. So again, if I pulled out that one whole in 10/10, then whatever I have left over is going to be the fraction next to my whole number. So I know that I have 1 and 6/10 as my answer. okay? Then right here, it says using a number bond to decompose 16/10 into a whole number and fraction helps me to blank. All right, and you can write what you want there. How does using that number bond to decompose that fraction greater than 1 into a whole and a fraction, what does it help you do? Okay. I'm going to write, it helps me convert to a mixed number. Okay. All right, now we are going to scroll down, and now we have to do these two all on our own. All right, so let's go ahead and read the first problem. So it says, Mr. Salazar cut his son's birthday cake into 8 equal pieces. All right, Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. All right, so they each ate 1 piece of cake. What fraction of the cake was left? Okay, so I've read the problem, underlined what I need to know, or what I know and what I'm trying to find out. Now I'm going to draw my tape diagram. All right, and let's go back. So we know that Mr. Salazar cut his son's birthday cake into 8 equal pieces. Okay, so I'm going to cut my tape diagram into 8 equal pieces. All right, and I'm going to label this as 1 whole because this is 1 whole birthday cake. Okay, now I know that Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. So each person ate 1. Okay, Mr., Mrs., and the birthday boy. All right, we want to know what fraction of the cake was left. Okay, so I know that Mr. Salazar ate a piece, I know that Mrs. Salazar ate a piece, and I know that the birthday boy ate a piece. So how many pieces of cake did we eat all together? Right, they ate 3 pieces of cake altogether. I know that we had 1 whole cake to start with, all right? But since we cut it into equal pieces, I want to write that 1 whole using 8, all right, using eighths. So I'm going to write 1 whole as 8 eighths. That's what they started with, right? That's the cake they started with. Then each of them ate 1 piece of cake. So altogether, there were 3 eighths of cake gone, right? And we can see that when we look at the tape diagram. So now we want to know what fraction of the cake was left. So if we subtract 8 eighths minus 3 eighths, I know that I can subtract these just like this because they have the same denominator. So I'm going to say, okay, what's 8 minus 3? That's going to give me 5 eighths, all right? So what fraction of the cake was left? We need to put our answer into a statement because this is a word problem. So I'm going to restate the question. What fraction of the cake was left? There was 5 eighths of the cake left. Okay? So you should have gotten 5 eighths as your final answer. All right. At the bottom it says Maria spent 4/7 of her money on a book and saved the rest. All right. So she spent 4/7 of her money on a book and saved the rest. We want to know what fraction of her money did Maria save. All right. So again, go ahead and draw that tape diagram. You know what to do. She spent 4/7 of her money. So since 7 is my denominator here, I'm going to divide this tape diagram into 7 equal pieces. Okay? And I'm going to label this as 1 whole. This is all of the money that she has, that Maria has. Okay? I know that she spent 4/7 of it. 1, 2, 3, 4. That's how much she spent. Okay? And I know that this is how much she saved, which is what we're trying to find out. Okay? What fraction of her money did Maria save? Okay, so we want to think of this tape diagram as all of the money that Maria has. So, and since our denominator is 7, I want to think of this as one whole, all right? So 1 whole is going to be the same as 7/7, all right? And if our whole is 7/7, we know that Maria spent 4/7 of her money. So that amount is gone. So if we subtract 7/7 minus 4/7, that's going to give us 3/7. So answering the question, what fraction of her money did Maria save? We want to say Maria saved 3/7 of her money. All right, go ahead and pause here or rewind if you need to catch up. I really, really want to encourage you to go on and try and finish the rest on your own and then come back and check. But if you want to or need to work through it with me, that's fine too. Okay, so when you're ready, go ahead and flip the page. We have 2 more problems. Okay, so looking at the first one up top, Miss Smith took her bird to the vet. Tweety weighed 1 3/10 pounds. Okay. The vet said that Tweety weighed 4/10 of a pound more last year. And they want to know, how much did Tweety weigh last year? Okay, so you know the drill. We read our problem. We underlined what we know, what we're trying to find out. Now we are going to draw. So I'm going to draw a tape diagram. All right. Okay, so I know that this year Tweety weighed 1 3/10 pounds. Okay, so I'm going to think, all right, I know that Tweety weighed 1 3/10 pounds. So I'm going to show that on my tape diagram, okay? I am going to say, okay, I know that there are going to be 10 units and 1 whole, right? Because 10 is my denominator, but I have 1 whole. So I'm going to say, and then I know that there's going to be 3 extra because my fraction next to my whole number is 3/10. So altogether, I know that I'm going to have 10 tenths plus 3 more, which is 13 tenths. So I'm going to draw 13 units inside this tape diagram. Oops. 1, 2, 3, 4, 5, 6. Okay. So, and then I know that 1 whole is 10 of them. Okay. So now I have 1 3/10, and that's how much Tweety weighed last year. Or no, that's how much Tweety weighed this year, I'm sorry. All right, so now, if this is this year, I need to figure out how much she weighed last year. And last year, Tweety weighed this same amount, but plus 4/10 of a pound more. All right, so I know that I'm going to have a tape diagram, and it's going to be at least this long plus 4 more, right? So once again, I'm going to do the same thing I did. I'm going to have 13 total pieces right here. Okay, and I know that 10 is going to be 1 whole. Okay, And but then I'm also gonna have an additional 4. So I already have this same amount as I do up top. Okay, but now I'm gonna go and I'm gonna add 4 more tenths. So 1, 2, 3, 4. All right, I've added these 4 more tenths right here. So I'm going to write, and what I'm trying to figure out, remember, is how much did Tweety weigh last year? This is what I'm trying to figure out. Okay, so I'm going to say, all right, she weighed 1 3/10 this year. And last year she weighed 4/10 of a pound more. So when I add those up together, I already have 1 whole, and then 3/10 plus 4/10 is going to give me 7/10. You can probably hear my cat in the background. All right, so how much did Tweety weigh last year? Last year, Tweety weighed 1 7/10 pounds. All right. Okay, so we have one more problem to do. All right, so going on down to the bottom, let's go ahead and look at this problem. And it says, Hudson picked 1 1/4 baskets of apples. Okay, Susie picked 2 baskets of apples. How many more baskets of apples did Susie pick than Hudson? All right, so I'm gonna go to those tape diagrams. I'm gonna have one for Hudson, and I'm gonna have one for Susie. Okay. And actually, I know that Susie's is a bit longer than Hudson's because Susie picked 2 baskets of apples and Hudson only picked 1 1/4. Okay. So, let's see. All right, so I'm gonna say this is Hudson and this is Susie. So Hudson picked 1 1/4 basket of apples. So I immediately know that 4 units are gonna make up 1 whole because 4 is my denominator. So if I already have 1 whole, that means I already have 4/4 baskets of apples plus 1/4 more. So that means altogether I have 5/4 baskets of apples. So I'm going to draw 5 units, but I'm going to show 1 whole over 4 units. So I have 1, 2, 3, 4, 5, but I'm just going to show 1 whole right here. So Hudson picked 1 1/4. So this is 1 whole and then 1 more 4th. Okay. Now going to Susie, I'm still going to think of this as 4ths, but I know that she picked 2 whole baskets of apples. Okay, Hudson picked 1 whole basket and then some more. Susie picked 2 whole baskets. So I know that already 4/4 is going to give me 1 whole, right? So I know that Susie already picked at least 4/4, right? Because that's 1 whole. And then she also picked another whole basket. So I'm going to draw 4 more 4ths. All right. So I can see that Susie picked a total of 8/4 baskets of apples because we have 1, 2, 3, 4, 5, 6, 7, 8/4. And I know that 8/4 is the same as 2. Okay. So now I can write this as, and we can write it in 2 ways, right? We could say Susie has 2 baskets of apples, and we said if we were writing that in 4ths, we know that 2 baskets of apples are written as 8/4 when we're thinking of 4ths. So 8/4 is equivalent to 2 wholes. So 8/4 minus, because it says how many more, which means I'm finding the difference, so I'm subtracting, minus how much Hudson picked, which is 1, 2, 3, 4, 5 fourths. So now I have 8 fourths minus 5 fourths, and that's going to give me a total of 3 fourths. Okay? So you could also say, okay, you were comparing to find how much more baskets of apples Susie picked than Hudson. I can see that the lines right here connected, and that was the equal amount that they picked. And then right here, I could see that we have 1, 2, 3 fourths more in Susie's basket. Okay, so restating that question, how many more baskets of apples did Susie pick than Hudson? Susie picked 3 fourths more baskets of apples than Hudson. All right. So that is all we have for today. I am also pretty sure now that we went through this, I think we did this, we had already gotten to this lesson before school closed as well. So if you need help on this, please reach out to me. I'm happy to get on a Microsoft Teams call with you. Anything that you need to work out these problems, just let me know what it is that you need. And don't forget to use the anchor charts if you need them in Microsoft Teams. All right, so reach out if you need help, and I will talk to you guys later. Bye.